Hey, good morning, Chem 20s. Here is a video for you on how to do net ionic equations. So we have already learned about what happens to a solution in water. So will that entity, that whatever the thing, right? That substance, that acid or base or whatever the substance is, we call it an entity. Is it going to dissolve? Is it going to dissociate? Or is it going to ionize? But now, what happens if these substances, these entities, are now reacting in solution? So we have to decide what entities are actually involved in the reaction. We don't care about any of the entities, the substances, the things that are not reacting. We're only concerned about what is the net, the overall reaction. And so that's what we're going to learn about here, these net ionic equations. So my first example to you is I've got silver nitrate and sodium chromate, and they're both solutions. And so if you were actually able to do this, you would see that we have these two kind of aqueous, clear colored solutions. And then when you combine them together, they actually form a solid precipitate, this white, cloudy stuff. And how do we know what exactly is reacting there? What is forming this white, cloudy stuff? What is reacting and what isn't? Well, that's the whole point of this. So step one, and this is just like Science 10. This is nothing new. You're just writing an equation, a balanced chemical equation. And in this case, it is a double replacement, right? We've got a compound silver nitrate and we've got the compound sodium chromate, and we get this precipitate, right? When you check your solubility table, and so we know this guy is aqueous because we're told it's a solution. We know this guy is aqueous. But then when you're forming the products, you have to check your solubility table and you'll see, oh, wow, this guy is a solid. This is a precipitate. So that's explaining this white cloudy stuff that we see up here. And then the other guy that forms, because it's a double replacement, and so we have two products being formed. Now this guy is aqueous. Again, we check our solubility table, and this is just like Science 10, right? This is nothing new. We balance it. We make sure our number of silvers on the left and our silvers on the right are equal in number, and there's no net charges or anything. So this is just normal Science 10. The next step is where it is different than Science 10, and that's where the stuff that you just learned about in the Arrhenius booklet, the dissolve, dissociate, ionize booklet, comes into play and becomes very important. So here, we're now going to look at this non-ionic equation and then ask ourselves for each of the entities, each of the things, the substances, is it ionic? Is it molecular? Is it an acid? Is it a base? So what happens to it in solution? Is it going to dissolve? Will it dissociate? Will it ionize? So we've got this table 3 that we have been using quite a bit. And it gives us our ionic compounds, which include bases. That's where we now then go to our solubility table. So anything that is an ionic compound, we look at our solubility table and we say, okay, well, is it going to be high solubility? Will it break apart into its ions? Or is it low solubility? Will it stay as a solid? So here's these two things that we have. We've got this guy aqueous and this guy aqueous. All right. And so now we're going to go to our solubility table and decide what happens to those two things. Okay. So our first one was AgNO3. Oh, here's the NO3 ion, and I see that most things are soluble. Most things are aqueous. Now, I just got to make sure that Ag is not down here. Oh, here's Ag. Oh, but it's not with NO3. In fact, nothing with NO3 is ever slightly soluble. It's always one of those ones that's always aqueous. And so I know that I can go back and I can split that apart. I can dissociate that compound. My next guy is sodium chromate. And if I look across here, I don't see chromate. It's not on here. So I know I have a group 1 ion. I know it is sodium ions. And I know that group 1 ions are soluble with everybody, right? Very soluble, except here's these couple of exceptions, rubidium and cesium. Those are the only two of group 1 ions that are not soluble out of probably a million different combinations. So I know then that the Na and the CrO4 2-, those guys are going to break apart. They're going to dissociate. Okay, and so that's what I'm going to do then when I look at my reaction. I take this silver nitrate and I am going to dissociate them. I break them up into their ions. Now remember, I had this coefficient of 2 here. That stays, right? I have to keep that coefficient to keep my charges and to keep my entities balanced. And that is a multiplier also for the NO3 ion, and that's why I have a 2 out front there. Now here I have a coefficient of 2, and yes, I'm breaking this apart, and that 2, sorry, this is a subscript, and now it becomes a coefficient. Now I don't have, there's just one of these, right, because he's a 2- ion, and so he stays with just a 1. Now, what do we do with these low solubility solids? Well, we learned that low solubility solids stay solid, so this precipitate stays as is. And again, I look on my solubility table. Here's sodium nitrate. Well, I just said that nitrate, and here's a group 1 ion. These guys are going to be very soluble, so I'm going to break him apart. I'm going to dissociate him into the ions that made him up in the first place. Okay, so now this is my total ionic equation. I've gone through and I have dissociated everything that could be, everything that didn't dissolve stayed as is, and then I'm going to go on, and my step 3 is going to be cancel the entities that are the same on both sides of the equation. We call these the spectator ions. They're not involved in the equation, so we don't care about them. They're not doing anything. So you will notice that the nitrate has a coefficient of 2 out front. Here he has a coefficient of 2 out front. We also notice what his charge is. So there's 2 negative, 2 negative. They're the same state. So they're the same. They're not changing in any way. They're not involved in the reaction, so we get rid of them. Same for sodium. Look, it's 2Na plus aqueous. 2Na plus aqueous. Get rid of him. He is not at all involved. And so therefore we cancel out these spectator ions. What are we left with? Well, we are left with the actual guys who are reacting. And so that leads us to our net ionic equation. These things that are left over is actually what's reacting in the equation. We've canceled out our spectators. Here's what's left. I had 2 silver ions and a chromate ion, and I made this precipitate Ag2 CrO4 solid. Now, you might think you're done, but you're not done yet. You've got to do your double check. You have to check on the left side and the right side and make sure your atoms, your entities, your things have the same number, and also your charges. So here's this multiplier of a 2 here for our silver. And over here, look at this. I have 2 silver. So my silver is good to go. Now I have 1 Cr over here, 1 Cr, 1 Cr, 1 Cr. We're good to go. And 4 O's on this side, 4 O's on this side. So my atoms are balanced. Now I have to check my charges. Remember, this 2 is a multiplier, so I have 2 positive and 2 negative. That adds to 0. On the product side, I have a compound, and I know compounds are neutral, so they also have a 0 charge. So we're good to go here, guys. We've done our double check, and we have now our net ionic equation. Okay, one thing I wanted to mention also to you guys, what if we didn't have ionic compounds? What if we had some molecular compounds, or what if we had some acids in our non-ionic equation? So we've got that table 3, but we also have this does it dissolve concept map, right? And so we just looked at what do we do if it's an ionic compound. We use our solubility table to decide, are we going to dissociate it or not? If it is a molecular compound, we have to decide, is it soluble? Does it become aqueous? Or is it non-soluble? Does it not dissolve? And it keeps its same state. And don't forget that on the back of this page, we also have what to do if it's an acid. So remember that if we have acids, we have 2 types of acids, right? We have strong acids and we have weak acids. And depending on whether it's strong or weak is going to determine, do we ionize it 100%? Well, yes, we do if it's a strong acid above hydronium. If it's a weak acid, it's below hydronium. We know it does ionize somewhat, but it's not enough to fully ionize because it's too weak. So we leave it as its molecular form and we just change the state to aqueous. Okay, so reminder, you have this sheet as well as your data booklet and your table. Going back to this table 3 as well. What is happening to that particular entity in solution? Does it dissolve? Does it dissociate? Does it ionize? So here's a quick summary of what we have done, our writing net ionic equations. So I'm going to do one more video, and this video is just a short one where I'm going to walk you through a practice example. Okay, and so I'm going to stop this video. There will be one more video in this net ionic series. Until then, talk to you later.